All right, in this section 10.5, we're going to be learning about a few different functions. And the first function here is called the absolute value function. Okay, and just a slight review, the absolute value, remember, is a number that when you plug in for x, what the absolute value does is it always makes it positive. And the reason why it always makes it positive is that it's taking how far is it away from 0. Okay, so if, for example, the absolute value of 5 is 5, because how far is 5 away from 0 on the number line? Well, it's 5 away. And if I said what's the absolute value of -5, again, the absolute value means how far is -5 away from 0? Well, it's still only 5 away. Okay, we don't say it's -5 away because we're talking about distance, and distance is always positive. So the absolute value always gives us positive values. All right, and so what I want to do right now is just let's just go ahead and plug in some values and see what the graph looks like. And the easiest way to do that is just to create a table of values. We have our x values, and then we have our y values, which is going to be absolute value of x. So I'm going to plug in an x, and this is my y value. So how about if I start with 0 in the middle? What's the absolute value of 0? Well, 0. And let's maybe do -1, -2, -3. The absolute value, if I plug in -1 right here, is 1. If I plug in -2 right here, is 2. If I plug in -3 right here, is 3. And if I did 1, 2, 3, the absolute value of all these guys is 1, 2, 3. All right. Now, if we plot all these points now, so these are coordinate points. This is the x. This is the y number, meaning this is the coordinate point -3, 3. This is the coordinate point -2, 2. This is the coordinate point -1, 1. All right, and then you can see how the pattern works there. So let's go and plot these. So over 3, up 3. So that would be 1 point right there. Over 2, up 2. That would be a point right there. -1, 1. And then at 0, 0 at the origin. And then 1, 1. 2, 2, and 3, 3. And you kind of see how it's going to give us a V shape. Okay, so the graph will look something like this. Bing. And there we go. So we're going to have nice arrows at the end of them because, you know, these graphs just keep going on forever, right? They're going to keep going and going and going and going. So the way that we represent that is by putting arrows. Okay, now, so this is just what the absolute value function looks like. That means that there's no stretching, there's no shifting, you know, like you learned earlier in chapter 10 when you had to graph quadratics and parabolas. Those had shifts and stretches, right? Well, in the same way, we're going to do stretching and shifting here. And you learned this earlier in this section, and that is that y equals a times the quantity x minus 8 squared plus k. This is the general form of a quadratic, where if we remember the vertex is hk, right? You learned about that. And you also learned that this a right here, it's either going to stretch or it's going to shrink the graph, right? So in the same way, actually, oh, and then you see this right here is the vertical shift. Right, so this makes the graph go up and down, and this right here, the h, is our horizontal shift. Okay, and so a little review there, and the reason why that I bring this up is because we actually have a very similar general form now for the absolute value function, meaning we can write, or we can either write or we're going to be graphing absolute values that look like this: a times the quantity, the absolute value of x minus h plus k. So look how similar it looks to this up here. So it's the same thing where a is your stretch or shrink, the h is our horizontal shift, the k is our vertical shift, And as a matter of fact, HK is the vertex. So it's very, very, very similar to the quadratic. Okay. And one last note in our introduction to the absolute value is the following. Notice that the pattern here, okay, that from the vertex, and maybe if I'll just do this in this color right here. So say if this right here is my vertex, notice that to get points from the right, it's going to go over 1, up 1, over 2, up 2, over 3, up 3. Okay, and as a matter of fact, it will always go over 1, up something. It will always go over 2, up something, and always over 3, up something. And so basically what I want to do right now is I want to show you just what the pattern is, so that when we graph these in the first example coming up here, we can graph them rather quickly by knowing this pattern. This is what I mean by that. So from the vertex, that means you will always go over 1, and you will always go up 1 times A. Again, our A is the leading coefficient of our absolute value, okay, right here. And if you want to get more points, okay, so that's going to give us 1 point right there. If you want to get a second point, you're always going to go over 2, and you will always go up 2 times A. Okay, and let me just move this over. Oh, try that again. I think I could do this. Hold on, sorry about that. Let's see. So if I move this guy over here, and my little point didn't quite follow. Okay, let me just erase that real quick. And see if I could do this. Okay, so from the vertex, you always go over 1, and you're going to go always up 1 times A. You're always going to go over 2, up 2 times A. And then if you want to get a third point, you're always going to go over 3, and then up 3 times A. And this pattern will continue indefinitely. And watch, you'll see what the purpose of this pattern is in the first example that I'm going to show you.